This is another section on core concepts. Understand the Kubernetes API Primitives. And this is about another library called Kustomize, which is another add-on tool that you can add to your environment that works very closely with kubectl. And what it does is it lets you do a lot of the same kind of things we did with Helm. And so there's a couple main themes. And I think the easiest way of describing this is just through example. But generally, the first feature it does is it does what's called setting cross-cutting fields. Basically allows you at the highest level is you have a bunch of config files and that don't have any templating in it, right? But you want to drive maybe labels across all of them, or you want to add prefixes to all of the names of the objects that are in all those files. And that's what this does. So let's look at by example, and it'll be more clear. So in the project file itself, you will see I've got I got a couple of YAML files, one of which is named customization with a K, and the other two are just regular. These are just two different config maps, right? One thing you notice here is the config maps, the configuration files themselves, the YAML files, have no templating language in it. So that's something different than Helm, where we actually use the curly braces, right? So here there is no templating, but we have this customization file. And I'm just going to read out what this customization file will do for us. So because this customization file is here, and it refers to the two resources, the example and example2 YAML files, when I go to use Kustomize, what's going to do is basically every object that's defined, so the two config maps, the names that are there will have a dash project as a suffix. Okay? And then it also will add labels automatically to all the objects that are defined. So it's going to add my project, and 010. So let's see this in action here. So again, you have to install Kustomize separately, but once it's installed, you can actually run the command here like this. You do kubectl kustomize. Wait, I can name the folder. Kubectl kustomize project. And what it'll do is if you run it that way, all it's going to do is generate out of that folder. It's going to generate the final output Kubernetes configuration files, and you notice that for each object, it added a dash project on both names, as well as added the labels for me. So that's an example of how it does cross-cutting labels or names, things like that. And then if you want to apply that and actually build stuff in your cluster, right? You would use kubectl apply. Normally you would do -f on a folder, but you use K for kustomize and then on project. And what that'll do is it'll automatically build the configs and then run them and send them to Kubernetes, and will build and you can see that it built my config maps. In fact, if I do kubectl get config map, you will notice that I have example project and example2 project, and the labels are already there. Okay, so that's sort of the feature set of how you use Kustomize. And then you can also delete everything that's there, so you can do kubectl delete -k project, and that will delete the two. So that's the first use case of it. Let's go to the next one. There's another feature where you can do patching. So again, I think the easiest to see this by example. So I'm going to close down this one. There's another folder called project patch, right? And so I've got 3 files. I have an example file, YAML file, which looks very familiar, right? It's just a normal config map, right? And then I look at a patch file. It looks very similar, but it just has an incremental difference. Here you notice it looks like a config map, but it only has a data on the same exact example, except for it has a data with ccantaloupe, right? And this is the patch. So conceptually what I'm doing is I'm going to take the example, and then I'm going to patch in, and I should see now ccantaloupe added to my final output. And the way this works is if you define a a suffix, customization file, in this case I have, I mean it's not necessary, but I also have the suffix, the common labels, right? I mentioned the resource example, and then I'm using a patch with a merge on patch.yaml. So let's see how this one works. If I do kube control, I'm not going to apply this. I'm just going to output the result, which is customize. And then it's what is this folder? This is project patch. And you'll notice the final output has A apple, B banana, and C cantaloupe, right? And of course the other part of it was it added the labels and the names, appended the suffix to the name. So that's an example of a patch, right? And conceptually, the idea, at least the way I look at it, is the patch is something you can do over time, where you can apply multiple patches on top of each other without actually editing the original file. You can make these incremental changes as necessary. So that's patches. There's another concept called bases and overlays. And again, I think it's easy to see by example. So what I'm going to do is we're going to go back in here. There's a folder called project base, and there's a folder called project, no, there's only a project base here. So I go in here. In project base, I've got 3 folders, a base, a dev, and a prod. So let's look at base first. This should look familiar. It's our regular config map, nothing special, and it's our actual regular customization file that just adds the suffix and that. So this is pretty much the same thing we saw the first time, right? So there's nothing new here. Where it's new is under dev. I just have a customization file, and you notice that the format here says I'm basically defining this to be based on, this is an overlay based on the base, and I'm going to override or change the behavior by making the namespace of every object created dev. And if you guess it right, the same thing is true for here for prod, except for I'm using prod, right? So the only difference between these two is that the namespaces should be different. So let's illustrate that in use. If I do kube control apply, no, I'm not doing apply, I'm doing customize, right? And then I'm doing project base dev. And you notice this is basically what you expect, apple, banana, the labels, but you notice the namespace is dev. And if I do the same thing with prod, you can see the namespace is prod. Now you could do more than namespace, but I just wanted to illustrate sort of a simple example of how the overlay works with the base. Okay, and then, so that's overlays. And the last example is, it's a little bit weird because we're using config maps in our example, but we'll look at it. So what this lets you do is essentially create config maps, but instead of having to define the config map using like the YAML format, right? What you do is you actually define the, I'm in the wrong file here. It's the project config map, right? What you basically do is you provide a file, in this case, A equals apple, B equals banana, right? You define your properties in some sort of external format that has nothing to do with YAML, right? And then what you do is in your customization file, right, you do what's called a config map generator, right? The name of it is example, right? We have the name suffix like we did earlier in the labels, right? And then we're basically pulling the config map from application properties. So what the output of this thing is actually the same thing we had done the first time. It is, we should see a config map named example-project with the labels, and then it should be pulling the A and B, apple, B banana from the properties file. Okay, so again, this is a little bit of a roundabout example because we've been only using config maps, but anyway, if you had a lot of other objects, this might be a convenient way to build their config maps. Customize, this should be project CM. And you notice that actually I have a bug here. Let me I noticed the data here did not look like what I'm expecting. It says data application properties is the key and the value is apple banana. That wasn't really what I intended, at least I was not expecting that. This might be the final result, but everything else looks fine. Let me pause the video for a second and see if I can figure out if there's a way to do this differently or this is the right answer. Give me a minute. Okay, I'm back. So it turns out that what I did was correct, except for it's not what I was intending. So when you pull it from a file like that, the key becomes like the file name, and the value of is the string. The value is like the entire file, right? And that's useful some pattern. What I was trying to do is replicate the original config map. And here the way you do this here is you use a different syntax. You say config map generator name, and you call out the literals specifically, and then you can pass them in this way, and that will then create your config map. So you can see this in action by now doing this, and now I've got my config map as expected. So it seems like to be honest, seems a little strange and roundabout way for me to create a config map. It almost seems easier just to create the config map directly, but this is probably more relevant when you're trying to pull in files, just like I did the first example where the value of a key is an entire file. So again, that's what the config map generator feature does. And I believe that is the end of this short video about how to use Kustomize to essentially do some of the management of your persistent objects in a more structured way. Now, to be honest, I think the rest of the video for now, I think I'm going to stick with Helm and not use Kustomize, just because it seems more familiar and it seems a little bit more powerful for what I'm trying to do, which is, patch management and stuff like that. So that's going forward, it's going to be using Helm.